SURDS in maths are where we end up, through our equations, with a square root of a number that doesn't have a good square root. It won't give us a whole number. For instance here, the square root of 8. We can say that it's going to be somewhere between 2 and 3, because 2 squared is 4 and 3 squared is 9, 8 being then between those, but we don't know what the decimal is going to be. You could put it in your calculator. However, certain calculators will only give an answer as a decimal. Obviously, in the phrasing I've just given, that's what we were looking for. But in an actual exam question, they may well ask you for exact form. And if it wants exact form, decimals just aren't good enough. We want it in this SURD. With that in mind then, if you are looking to get an answer in SURDS and your calculator is only giving you an answer in a decimal, we may have to know how to work these through manually. Now, if you're looking to change a SURD, therefore, nevertheless, maybe because the answer wants it in a very specific form, it wants a specific, the square root of something, which is not the number you currently have, or if you have multiple SURDs in either your working or your answer that you want to try to combine together into a single SURD, what we have to do is to look at what factors times together to make this number. In the instance of 8, we could say that this would be the same as root of 4 times 2. Now, if it is a multiplication inside the square root, you can split it up into 2 separate square roots. Not any other sign, though. It has to be a multiplication, so not plus, not minus, not divide. It has to be times. But if we can do this, we can then see here that the square root of 4 is going to be 2. So you have 2 root 2, and this would be a simplified version of root 8 because the number that's left under the square root is smaller. And how we're able to do that is we're able to find not only a factor, but a factor that was in itself a square number, because obviously that then cancels with the square root. So, throughout this, we're going to be specifically looking for what square numbers can we identify. Just to list those in so we have them. Technically, you have 1, but taking out a factor of 1 isn't going to make a difference. Then 2 times 2 will be 4, 3 times 3, 9, then 2, 16, 25, 36, 49, 64, 81, and 100, and of course it keeps going, but even then, these higher values you're probably not going to be finding. You're probably going to be looking at this lower range. Knowing this, we can now use this technique to help us add or minus some SURDs from each other. So let's take this same root 8 from before, but now we wish to add to it the square root of 18. As it stands, we have no way of combining these together. It would have to stay like this. But if we can make them both in terms of root 2, we can then combine them together with a single coefficient, just as if that root 2 was an x or a letter in algebra. There we already know that the square root of 8 can be written as 2 root 2. And as for the 18 here, well, that could be 9 times 2, so that will then be root 9, root 2, and the square root of 9 is 3. So we have 2 root 2 add 3 root 2, so combined that will be 5 root 2. If this had been a minus, then it just would have been minus root 2. And similarly, as we get onto an example a little later, we could have also in fact done this as a division, where the square roots would have cancelled with each other, and then you would have ended up with just 2 over 3, so 2/3. If this is how we can combine some SURDs by rewriting them then, there's another thing we can also do, which is to change how we're going to write a fraction. Not the value of the fraction, we don't want to change the value just yet. We just want to rewrite it in a way that will again make it easier to combine with other things. This is called rationalizing, or rationalizing the denominator. Here, we don't like the fact that there is a SURD in the denominator. It'll be okay if it's in a numerator, but it cannot be on the bottom. In order to stop this square root 8 from being a square root, therefore, what we're going to do is we're going to times it by itself. Now, if you're going to do something to the bottom of a fraction, you have to do the same to the top. It's just as how when you're making a common denominator to add or minus fractions, whatever's on the bottom has to be the top. Here, so if we're now timesing by root 8 on the bottom, you're also going to times by root 8 on the top. Multiplying fractions is now just top times top, bottom times bottom. So 1 times root 8 is root 8. And down here, the square root times itself is just going to be that number. So in this case, root 8 times root 8, if you wanted, that would be root 64. You're just basically doing the reverse here. So the two square roots times is the same as one square root of those two numbers times together. So 8 times 8 is 64. And the square root of 8 is 64 is 8. Either way, you end up with root 8 over 8. This here, the root 8, as we know, can be rewritten as 2 root 2, so 2 root 2 over 8. And the 2 and the 8 here can simplify slightly to get root 2 over 4. If, however, there's more than one term in the denominator, let's say that instead we had 2 over 5 plus root 7. We're still going to times by basically the denominator. But in this case, to make it fully disappear, what we're going to do is we're going to do it with the opposite sign. So if there's a plus here, we'll then make it a minus like this, and obviously the same on the top again, to not change the actual value of the fraction. Because if you times by, or anything divided by itself is 1, and timesing by 1 makes no actual difference to the value. On top here, therefore, you end up with 2 times 5 is 10, and then 2 times the minus root 7 is minus 2 root 7. Then on the bottom, 5 times 5 will be 25. 5 times minus root 7 will be minus 5 root 7. But then root 7 times 5 is plus 5 root 7. And the minus and the plus of the same term make them cancel. That's why we did this opposite sign. And at the end here, root 7 times minus root 7, well, root 7 times root 7 would just be 7. So here then it's minus. Just to finish up with then, so that'll be still 10 minus 2 root 7 on top. On the bottom, 25 minus 7 is going to give us 18. And this you could just divide through by a factor of 2. So it's 5 minus root 7 over 9. If you're not 100% clear on what we did when we were timesing these two denominators together, so we're just treating them like brackets and so you're timesing together two brackets, I would suggest looking for the expanding and factorising quadratics video. If otherwise, we're good with these kind of principles here though, so how we can look to separate the number inside a surd into two other numbers, which are factors, one of which is a square number, so that that square root can disappear, and how we can then use that to combine surds by turning them to the same base surd, or how we can rationalise a denominator here to make the bottom of a fraction a whole number. Let's just see how we can get along with questions of our own. Let's say, first of all, if we were to have the square root of 80 plus 30 over root 5. Then next, if we were to say we had 12 root 3 over root 50 minus root 18. And then lastly, root 2 over 2 root 5 minus 3 root 2. Could you think of ways in which we could simplify these expressions? Pause the video, have a go for yourself, and then press play again when you're ready to compare. So, with this first one, because we're looking at root 5s here, let's just think about how we could turn this into a root 5. Well, 80, if you were to divide it by 5, is going to be 16. So that's like root 16 root 5, which will just be 4 root 5. Now, as for this second term here, obviously we're going to want to rationalise the denominator. So if we think of this as 30 over root 5 times root 5 over root 5, that's going to get us on the top 30 root 5, and on the bottom root 5 times root 5 is just going to be 5. 30 is going to cancel with the 5, just to leave us with 6 here. So we have 4 root 5, add 6 root 5, together making 10 root 5. Next, we're going to want to once again rationalize the denominator. We can actually either do this first, or we could simplify this denominator by combining it into a single term. As here, both of these, the root 50 and the root 18, are going to be able to be turned into multiples of root 2. We already know that root 18 can be turned into 3 root 2. So if we just focus on the root 50, well, that would be the same as root 25 root 2, so that's then minus 3 root 2, and root 25 is going to be 5. So here we have 12 root 3 over, now 5 root 2 minus 3 root 2 leaves you with 2 lots of root 2, and this we're then just going to rationalize now. So if we now times this by the 2 root 2 over 2 root 2, on the top, 12 times 2 is going to be 24, and then the root 3 times the root 2 is going to be root 6. And beneath this, 2 times 2 is going to be 4, root 2 times root 2 is going to be 2, 4 times 2 is going to be 8. The 24 and the 8 are now going to cancel with each other, leaving us with just 3 root 6. And lastly down here, while the denominator is once again surd minus surd, we cannot do the same trick that we did in the second example because there's no way of simplifying those surds down any further into being the same surd. So we do just have to go straight into the rationalizing. So we'll times by 2 root 5 plus 3 root 2 here, because we want to make the sign the opposite when we have multiple terms. So on the top now, 2 root 5 times root 2 is just going to be 2 root 10, and then 3 root 2 times root 2, well, root 2 times root 2 is going to be 2, 3 times 2 is 6, so plus 6. And on the bottom, 2 times 2 is 4, root 5 times root 5 is 5, 4 times 5 is 20. And following that, minus 3 times 3 is going to be minus 9, and root 2 times root 2 is again 2, so minus 9 times 2 is going to be minus 18. We don't have to worry about the middle terms, because once again, if you were to do the 2 root 5 times the 3 root 2 and the minus 3 root 2 times the 2 root 5, you'd have the same term, just one is a plus, one is a minus, so they would cancel with each other. Just simplifying down at the end then, 2 root 10 plus 6, this is over 2, and cancel through by a factor of 2, leaving you with root 10 plus 3. This then really is the extent of what we can do with surds. You may just have some larger numbers, or a few more you have to combine together, but if you have found that these crop up as part of the working for a larger question and a different topic, all you have to worry about is, try to simplify these down if you can into the same base surd, so you can maybe combine or divide or something maybe like that. Instead, you're going to rationalize, so be sure to times the top and the bottom by the same thing and make that thing on the bottom whatever's going to make the square root here disappear. If it's a single term, just the same thing as it was, or if there's multiple terms with an opposite sign. And all in all, this is just going to be either to help you spot something where you can then divide through by a common factor, or because the question is simply asking for it in a specific form, either just an exact surd form in a single term, or they want it to be specifically like square root 2, square root 3, and your calculator may only be giving you decimals. Just want to make sure that we're not entirely reliant on that, and that we can work it through this way as well.